NASA provided significant insights. Pluto isn't what you think. What is NASA proposing here? Are they interpreting the most recent findings from the New Horizons space probe, which suggests that odd things are happening on Pluto's surface? One of the remarkable images, in fact, shows an object that appears to float across Pluto's crust. This raises unsettling questions about whether some form of advanced alien life exists on this distant world, or if we are dealing with a bizarre geological phenomenon. Pluto might be small, but the stories it has to tell are immense and full of surprises. When Pluto's planetary status was revoked in 2006, scientists were unaware of the data from the New Horizons probe, which arrived shortly thereafter. Since then, we've learned there is far more to this dwarf planet than initially thought. How did astronomers come to deny its status as a planet? The decision to reclassify it as a dwarf planet followed the discovery of numerous other small planets in the Kuiper Belt. They determined that a distinction was needed between what constitutes a planet and what qualifies as a smaller body or trans-Neptunian object. Pluto meets the criteria for size and spherical shape, but it shares its orbit with several other objects, making its orbit less clean. This was the rationale behind Pluto's removal from the list of major planets in our solar system. Many people on Earth found this disappointing, and the decision by astronomers caused widespread dismay. The idea of Pluto no longer being a planet was an unsettling thought for many. The fact that this quirky little world had so many fans led to letters of protest being sent to NASA, including from prominent scientists and even government organizations. They demanded that Pluto be reinstated as a planet. Since its discovery in the 1930s, Pluto had been a significant part of our understanding of the 9 planets, a fact that made this reclassification hard to accept. In 2015, the New Horizons mission gave us our first real image of Pluto, revealing its fascinating surface. Imagine, it was the first genuine picture of Pluto. Before this, any images you might have seen in textbooks or school materials were artistic interpretations, not photographs. Even the Hubble telescope struggled to get a clear view of Pluto's surface. New Horizons, however, captured Pluto as it truly is, magnificent, complex, and with a heart-shaped feature that captured public imagination. Since then, this tiny world on the outer edge of the solar system has gained even more fans. Perhaps one day, astronomers will change their stance, and Pluto will reclaim its status as a planet. The stunning images from New Horizons turned heads and changed minds. When the first data from the spacecraft arrived at Mission Control in 2015, everyone present knew they were about to see a planet up close for the first time, one that everyone was familiar with but had never truly seen. The revelations from New Horizons completely changed our understanding of this distant world. Pluto is far more complex, dynamic, and alive than scientists had previously believed. Its surface is covered with striking features and surprising geological phenomena. Instead of a cold, cratered wasteland, Pluto turned out to be an active place with bright patches of ice, deep canyons, and smooth frozen plains. It took years for the data, photographs, and discoveries to make their journey back to Earth, but since 2015, we've been amazed by the unfolding mysteries of Pluto. One intriguing image from 2016 even appeared to show a figure walking across Pluto's surface. While the image captivated the media, researchers determined that the figure was actually a large chunk of ice seemingly floating across the icy terrain. This block of ice is thought to be composed of solid nitrogen and appears to float due to processes within Pluto's surface layers. These unusual landforms provide remarkable evidence of activity beneath the surface. Scientists now believe there is a reservoir of nitrogen beneath Pluto's crust, where solid blocks form and are pushed upward, creating the honeycomb-like terrain and wandering mountains. This evidence suggests a warm interior within Pluto, a discovery with wide implications for how we interpret this dwarf planet. The geological activity, combined with surface changes, indicates a form of aliveness that suggests we may have underestimated Pluto. This tiny world seems to harbor an internal heat source that could maintain pockets of liquid, similar to oceans or magma chambers. William McKinnon, a geophysicist on the New Horizons mission, compared Pluto's interior to something as vast as Hudson Bay in Canada. These insights reveal that Pluto is far more dynamic than previously thought. Pluto's heart-shaped region, named Sputnik Planitia, is another surprising feature. This vast icy plain spans about 1,000 kilometers and consists primarily of nitrogen ice, with traces of frozen methane and carbon monoxide. Its smooth, bright surface contrasts sharply with the darker, more rugged areas around it. Scientists believe Sputnik Planitia is constantly renewed by internal processes, likely involving convection within its ice layers. Beneath its surface, there may even be a subglacial ocean kept liquid by internal heat sources. While it's uncertain if life could exist in such an environment, the possibility isn't entirely ruled out. Pluto also has moons, the largest of which is Charon, discovered in 1978. Charon, Pluto's largest moon, plays a significant role in the Pluto system, measuring about half the size of Pluto itself. Charon is so large in comparison that the two objects are sometimes referred to as a double dwarf planet system. The gravitational interaction between Pluto and Charon causes both bodies to face each other with the same side at all times, a phenomenon known as tidal locking. This unique relationship also causes the two to orbit a common center of mass that lies outside Pluto, making their orbital dance distinct from that of most planet-moon systems. Charon's surface is starkly different from Pluto's. While Pluto boasts bright, icy plains and mysterious geological features, Charon's surface is darker, more rugged, and covered with water ice rather than nitrogen or methane. One of its most striking features is a massive canyon system that stretches across much of its surface, suggesting that Charon may have experienced internal geological upheavals in the distant past. Additionally, its north pole is coated with a reddish material, thought to be tholins, organic molecules that form when solar radiation interacts with methane escaping from Pluto's atmosphere. The interplay between Pluto and Charon has provided valuable insights into tidal heating and the dynamics of binary systems. The discoveries from the New Horizons mission not only deepen our understanding of Pluto and its moons, but also inspired curiosity about other icy worlds in the Kuiper Belt. These findings have implications for the study of exoplanets and the potential for life in extreme environments. The Kuiper Belt and Pluto's importance. Pluto resides in the Kuiper Belt, a vast region of icy bodies beyond Neptune's orbit. This area is home to thousands of small, frozen worlds, remnants from the early solar system. The study of Pluto and its neighbors provides a window into the processes that shaped our planetary system billions of years ago. Before New Horizons, our understanding of the Kuiper Belt was limited. Now, Pluto has become a key to unraveling the mysteries of this distant region. The Kuiper Belt isn't just a collection of icy debris. It's a dynamic environment with objects ranging in size from tiny rocks to dwarf planets like Pluto and Eris. These bodies have preserved conditions from the early solar system, making them natural laboratories for studying planetary formation. The discovery of cryovolcanism, internal heat sources, and complex surface features on Pluto suggest that other Kuiper Belt objects may also harbor surprising activity. Could Pluto be reclassified as a planet? Since the reclassification of Pluto as a dwarf planet in 2006, there has been ongoing debate among scientists and the public about its planetary status. Supporters of Pluto's reinstatement argue that its geological complexity and active surface challenge the criteria set by the International Astronomical Union (IU). Critics of the current definition point out that it excludes fascinating worlds like Pluto, which exhibit many characteristics traditionally associated with planets. In recent years, some astronomers have proposed expanding the definition of a planet to include any round object that orbits a star, regardless of whether it clears its orbital path. This broader definition would restore Pluto's planetary status and elevate many other objects in the Kuiper Belt to planetary status as well. While no official changes have been made, the debate underscores how our understanding of the solar system continues to evolve. The future of Pluto exploration. The New Horizons mission was just the beginning of our exploration of Pluto. Future missions could involve orbiters or landers to study its surface and interior in greater detail. Advances in technology may one day allow us to probe beneath Pluto's icy crust, searching for signs of subsurface oceans and even potential life. Missions to the Kuiper Belt as a whole could provide a more comprehensive view of this distant region, revealing the diversity and complexity of its many worlds. Pluto, once dismissed as a cold, inactive body at the edge of the solar system, has emerged as a dynamic and intriguing world. Its complex surface, active geology, and interaction with its moons have made it a centerpiece of modern planetary science. As we continue to uncover its secrets, Pluto reminds us of the boundless potential for discovery in the far reaches of our solar system.